Hello, my name is Daniel Fitter, and before I describe to you my project, I would first like you all to put yourself in someone else's shoes. Imagine this: you're a young child walking with your parent in a shopping centre. It is busy, noisy, and easy to get lost, but you know your parent is right beside you. Now, imagine somebody turns off the lights. It is busy and therefore noisy. You cannot hear your parent easily. Sound is one of your only senses remaining. You are no longer sure if your parent is near or far, and you begin to become distressed. You panic. In fact, the entire time your parent was right by your side. There was nothing to fear, but you did not know that. How were you to know? This is one example of many which demonstrates the stressfulness and helplessness a young child with visual impairment may experience, and is one of the key motivators for the project I am about to explain in this talk. The preeminent proposal of this report is to investigate the feasibility of using Bluetooth 5.1 to perform localization of two targets with respect to each other, without the need for static transmitters or receivers. With the release of Bluetooth 5.1 at the beginning of 2019 came the inclusion of angle of arrival, angle of departure, and mesh capabilities to devices equipped with these new chips. This has enabled the application of Bluetooth 5.1 to a number of problems that require accurate tracking of some target within a defined physical environment. But what if the environment is not defined and the information desired is that of relative position between two mobile targets? I plan to look at developing a technology demonstration system that implements the Bluetooth 5.1 or newer standard to provide accurate relative localization information of two people within a potentially crowded environment. Performing localization with Bluetooth is not new. The method used with previous Bluetooth standards, earlier than 5.1, was that of measuring the received signal strength indicator and using this to compute a distance estimate. This has been shown to have an accuracy no better than approximately 3 meters, and this accuracy is very dependent on the actual distance, objects between the targets, and multipath effects such as reflections from walls and ceiling. Sensor fusion methods have also been employed in conjunction with this, however few improvements have been realized. A more recent approach, utilizing AOA and AOD with Bluetooth 5.1 and newer chips, is capable of angle accuracies of less than 3 degrees, and if triangulation is applied, is able to compute position to less than 50 centimeters of accuracy. The current companies that produce these chips are Nordic Semiconductor and Silicon Labs, the latter currently having commercially available chips already equipped with antenna arrays. Despite this, the only commercially available product is bulky and not suited to portable use. Currently, the predominant applications using this technology are the tracking of assets within a warehouse and navigation within a shopping mall or airport. Both of these applications use static transmitters with multiple antennas to perform the localization tasks within a known, geometrically defined environment. There appears to be no research into performing relative localization between two targets in an unknown environment when one or both targets, the receiver and the transmitter, are moving. A consequence of this lack of research is that it is uncertain if Bluetooth 5.1 or newer standards are capable of meeting the requirements of this application. To complete this project, the following would be necessary: perform a literature review of distance and localization methods currently being employed by both large and small-scale applications. Investigate the current uses of Bluetooth 5.1 and newer standards, specifically in the field of localization. Assuming that Bluetooth for this application is not by now ruled out, thoroughly review and learn the current Bluetooth 5.1 standard, develop and test a demonstration system that utilizes stationary Bluetooth 5.1 transmitters in order to validate and quantitatively assess the performance of Bluetooth in respect to the proposed application. Finally, progress to assessing the system performance when both the target and receiver are mobile. It is expected that the project's significant outcome will be a confident statement regarding the current capability or otherwise of Bluetooth 5.1 to perform accurate localization between two moving targets using portable, low-cost, low-energy devices. The expected resources I will require to complete this project are as follows: 2 Nordic Semiconductor NRF 5340 development kits, a linear patch antenna array of at least 2 patches or a fabricated antenna array of at least 2 bow ties to perform the AOA and AOD, a Windows-based PC with internet access, and finally, participants to assist in the testing of the real-world applications of this device. Thank you for listening. If you would like to supervise me for this project, please get in touch by using the details on the screen or in the description below.